5 times 5 is?
25.
Yeah. Hey folks, welcome and welcome. We are so glad you've tuned into our Mathline show this afternoon. I'm Ernie Roberts. I am your host for this afternoon's version of Specialized Segments. And you know what goes on with Specialized Segments? It's when you get to sit back, relax. We're going to do some math together. It's not a call-in day, but we are going to look at a special topic, and we're going to dig deep. And you know, we're going to have some fun with it today. It's going to be a little creative. Get some pencil, get some paper, but I don't think you're going to need a calculator for this one. Absolutely not. This is all about thinking and analyzing and all sorts of other good things, and we're going to do it with brain power. How about it? What better thought? And again, you can check us out on Facebook. You can check us out on YouTube with this, but today it's not a call-in. So let's go right on and see what we're going to be doing with this brain power we've got going today. We have chains of logic, and that's one of the big things in math that we hopefully can learn how to think logically. It's how we solve problems. That's how we get ideas together. That's how we come to new conclusions based on data. We run them through these chains of logic and see where things come up. So we're going to get basic today, and let's see our first situation we want to go back to in order to do chains of logic. We're going back to conditional sentences, all right? And I've already boxed in two parts of this conditional sentence, but let's go back and look at some other words. The converse, the inverse, and especially the contrapositive. They're going to be helpful to us today as we get into these chains of logical sequencing and reasoning and thinking, brain power, like I said. That's what we're after today. Now, starting off, let's go back to a couple of basic things. We'll get converse, inverse, and contrapositive in just a second. But remember, we had a word for this part. This is the hypothesis, not the if, but it is raining. So the hypothesis is blocked in. The if is just an indicator. It's telling me, hey, signaling, there's a hypothesis coming out. That's our conditional part, all right? Then we have a conclusion, and we'll call this the C for conclusion. We're going to start coding a lot today in a lot of our situations to take, well, first of all, it saves us time, and also it's easier to see where things are going when we code them down to just maybe one letter per concept. So a H and a C for right now for hypothesis and conclusion, but let's go even a little better. Since the hypothesis is about rain and the clouds are your conclusion, let's use R and C. So refreshing our memory, we're going to use the implication mode. You say, what is implication mode? Well, it's kind of a nice fancy way of saying, we're going to say that if R implies C. This is, folks, this is our conditional sentence. In other words, if rain, then clouds. How about that? So this is the conditional, and we usually say sentence with it, or a CS for short. I'll be CSing from here on out probably in the show. Then we start messing with the sentence. All right, by the way, that's pretty much true. Unless someone's got that little hose that's running water over the top of you and fooling you in this middle of the summer. Oh, it's raining outside the window, the sun's shining. Well, someone's got a water hose scraping at you or something. But anyway, you get the idea. This is a true statement. We're going to talk about validity. Validity, I can say that word. The validity, how valid is that? It's true, all right? You don't see, you kind of go, what? Where does rain come from? It comes from the clouds. It comes from condensation. Now, we're going to go in reverse, though. Let's say if we have clouds in the sky, then it's raining, okay? That's what that's implying. The clouds, then it's raining, okay? Now, I don't know about you, but many days I've seen it cloudy, but no rain coming out of the sky. So you say, well, Ernie, what's this about? Is this the same thought of the sentence? No, it's not. We have reversed the hypothesis and the conclusion. So this is what we call the converse. And oh my goodness, this one is basically false. You say, well, why is it false? It could be true. Yes, it could be. But if it's not true 100% of the time, and we can find a counterexample in Tennessee and Kentucky and North Carolina and Virginia, we see many days where it's cloudy, and it's just cloudy, all right? And nothing's happening beyond that. No rain, no snow, no precipitation. So converse is not always true. Yes, it could be, but since it's not always, that's what we have to go with. We'll go with the false. Now, that's the converse. What do? We reverse the hypothesis and conclusion of the original conditional sentence. Now, let's go to our next layer. The inverse. Inverse just implies opposites, all right? And it's exactly what it is. Not only the opposite of the hypothesis, but also the opposite of the conclusion. Boy, you say opposite a lot of times. You may see me spraying you out there, right? But we are going to talk about the opposite, which, so we put a little squiggle there. That means negate. All right, that means the opposite. And it's going to go with the opposite of the conclusion. In this case, that would say it's not raining, then there are no clouds in the sky. Well, again, I've seen days when it's not raining. By the way, that comes first, all right? The not raining comes first. I've seen days when it's not raining and there will still be clouds in the sky. So you know what? The inverse and converse, and that's, by the way, that's what the inverse is. That's when we get into the negations. These work together pretty much. I'll tell you something. If you have a false converse, you're going to have a false inverse. Got a true converse, guess what? You're going to have a true inverse. That's the way logic is working in these four parts. Now, we got one more to go. Contrapositive here. And this is where we switch everything around again. You say, what do you mean? Well, we're going to either switch, we're going to make an inverse of the converse, or the converse of the inverse. However you want to look at it. So we started with R implying C, if raining then clouds. So what we're going to do, we're going to totally negate and switch the order. Whoa, that's just a whole big thought, isn't it? So we're going to put basically we're going to take not cloudy in the sky gives us no rain, okay? In other words, remember, these are not clouds. And if there are no clouds in the sky, guess what? Absolutely, there will be no rain. And you know, that's pretty much the same thing as what we started with. If it's raining, then there are clouds in the sky. But if we don't have any clouds in the sky, then we aren't going to have any rain. Absolutely. And that, folks, is what we call the contrapositive. And guess what? It's back to true. I want to tell you something. These two guys here are also logically equivalent. That means we can interchange those thoughts and we'll still keep the basic fact that we start with a falsehood, we're going to stay false. If we start with the truth, we're going to stay true. All right? So these are what we call logically equivalent. Now, it's going to come in handy in part of our chains of logic today. I hope we'd get there. Now, over here, remember, these two guys, they're basically logically equivalent also. The converse and the inverse, they worked together. I've already made mention of that. So those are important things to remember. The conditional sentence and its contrapositive will always be logically equivalent. A big, big important fact as we get into our chains of logic. So that's where we start. We are going to move with a good bit of just, you're going to think, where's the math today? The math is in your brain. It's what you're thinking. You're looking for patterns. You're looking for ways to order and sequence. You're getting logic going. So trust me, this is a strong mathematics skill. So let's talk about what a chain of logic, a nice fancy word for it is called a syllogism. And let's see what we've got here. It's a connected chain or sequence of events or ideas which come together in a relation, and I used a property that I hope we've heard of, all right? They teach this so much in the schools. It's an important moment. It's basically so much of what geometry works with, also your algebra, and if you haven't heard it, it's not a hard concept. But what it basically says, and it makes sense, it will make total sense to us all. It says, if A equals B and B equals C, then guess what? A should equal C. In other words, we've got this kind of like a middleman or a middle idea we're going to have in just a minute with our syllogism. So what you're going to see is things like maybe if A idea is some sort of concept leads to B and B takes you to C, then guess what? We also know that A will lead us to the idea of C. Now, a lot of times, notice there will be some intermediary steps. There will be some intermediate steps, like here's the B that connects us. When we're looking at those, that's kind of the same thing with transitive here. Sometimes we want to even call that substitution, and you can get away with substitution. But also, if you remember with transitive, we went and made angles that were congruent. If angle A was congruent to angle B and angle B congruent to angle C, then get what? Angle A congruent to angle C. That is your transitive property for congruence. You could do it for segments. You could do it for triangles. You could do it for similar triangles. Oh my goodness, there were a lot of ideas that the transitive property relates. But also transitive can move ideas. And that's what we're going to be dealing with when we talk about this syllogism today. We're going to try to connect the chain or sequence of events or ideas coming together in a relation similar to the transitive property, by the way, you may even come up with a new idea, a new connection between two things. Because guess what? You start here and you end up here and say, skip the middleman. But many times you got to have the middleman in there and show the whole syllogism for the proof and the validity of it. That's what proofing is all about. What leads to what, then leads to another, then leads to another. So that's what we're after today. That's what we're after today is syllogisms and getting those sequences rolling, etc. Let's look at one more quick one here, just giving you a little more practice here. It says, if P implies Q, remember what we said? That basically is saying that P leads to the idea of Q, and here we've got it, Q leading to the idea of R, then guess what? Oh, by the way, that's an and in there. We need to put that there because that's true, both of those, and this is a big if. What's our conclusion? That's the then part. Remember? Oh my goodness, here, hypothesis, two of them actually. And then we're going to pull them together and come to a great conclusion. That means we can go from there to P implying R. And that is, again, that's a chain of logic and using our structure of syllogism, all right? So, not a hard concept? Absolutely not. I think it's kind of fun because we're going to make some interesting ideas for you here. So I hope you're staying with us here. Stick with this whole show because we've got some good examples, and also we're going to twist this thing around a little bit. You know, remember I talked about those things with, conditional sentence, inverse, converse, and of course that contrapositive. We've got to watch out for some of those situations happening. So let's take a look at a very, very important issue with our teenagers, all right? And especially the guys. Jack studies hard tonight, then he can get a date for Saturday night. Did you guys know that? If you study, you can get a date. Goodness, how does that work? How does that work? Well, let's see. First of all, it works like this. First of all, we're going to set it up in coding, all right, with the letters here. We're going to say Jack studies. And what does that studying lead to? It hopefully leads to a good grade. Good grade, how about it? Leads to happy parents. Happy parents lead you to Saturday night being free. And then Saturday night leads you to, hey, you can get a date. Now, didn't say you will get a date, but you could get a date, all right, if you have those free. Now, what I want you to notice here is, we started off with S here. That's where Jack was studying very hard, all right, studying hard. And what happened here? When we went to G, he got good grades, all right. Now notice there's a connection. There's that syllogism business happening, all right. So right now we've got, he studied hard, so what was this? What was the H standing for? I'm trying to remember. What was it? We had what? Good grades, and then he has happy parents, right? So that makes the happy parents. So the happy parents lead him to evidently not being grounded, all right? He can get away on Saturday night. He can get out, all right? Then Saturday night comes back again and leaves you with the D. So guess what? Our studying leads to a date. And how about that, guys? You just didn't know there was a good reason why you use academics, right? Study and get a good date for your Saturday night, all right? So that's, again, that's an extended syllogism, actually. If you'll notice, we had a chain of logic. We had a lot of things going on there. And I'll be honest with you, a lot of times our teenagers and our students and even our adults can go through a convoluted measure to get from point A to point D, in that case, I guess, isn't it? Point S to point D. So there you have it, a little bit of a nice practical and a little humorous, hopefully, syllogism for you. Let's do some syllogisms of our own. Let's make some puzzles happen, all right, here. I've got a couple, and it says, what conclusion can be drawn from the following symbols, okay? Now, what I want us to go for here, we're looking for a new conclusion. There are a lot of conclusions already going on here. And again, what is a W, what is Y? We're not really concerned with that. We are just matching. Now, what are these little squiggles? Remember, that means those are the knots. And you say, oh, Ernie, what's going to happen when we have a knot appear once in a while? Well, you know what? We may have to look at a way to get these into order. So let's start first with the one on the left. We're going to let you try this one after you see me go through a process here, all right? Now, starting off, I want to do this. I want to pick out where I have no overlap in letters. What do you mean, Ernie? In other words, do I have repeating W? I see a repeating W, so that's an overlap. I don't want to start there with W, okay? I see these not A's overlapping. I don't want to start there. Looks like Y's are overlapping. So where do we go to begin? We are going to look for letters that have no overlaps. I see a G. Sounds like we probably want to end up there. And let's see, how about, does W have an overlap? W has an overlap. A has, oh, Z does not have an overlap, does it, folks? Z is where we will like to start. So what we're going to do, we're going to order these things. These are out of order. You remember when you did that in English class? You would read these sentences and you'd have to put them in order and make a story. Well, that's what we're doing here. We're going to make a story happen starting with Z, and we're going to say it leads to this concept of whatever not A is. And this is a not there. That's okay. That's okay. Reason it's okay? Because we have a not A coming right in play here. And by the way, just to keep you honest, let's put a check once we move them into the new order and we get it rolling. So here we go. We get not A, which leads us to the idea of W. W kicks on along, leading us to Y. See how the story is going? Everybody knows what's going to happen now, right? We're going to end up with what? W? No, we're going to end up with Y. Let me see if I can get that right. We've already used our W, haven't we? We're going with Y leading to G. And what's the connection? Say goodbye to the not A's, goodbye to the W's, goodbye to the Y's. We are left with what? Z leading to G. Now again, Z is some ideas, Z is some thought. We didn't have a chance to really go through. I just want you to play with the letters right now. We'll put some words up there again and make you code and order them and have some fun with it. But there it is, pretty straightforward. So again, the clue is you want to have overlaps. And we're going to have some overlaps over here. You're going to be looking for letters that overlap, and you're going to look for letters that don't have any counterparts. In other words, there's only one of them. And eventually, you're going to try to come up with some way they all connect. And this one's sort of set up for you, it looks like, isn't it? Well, maybe, maybe not. We'll have to think about that, won't we? But right now, while we've got this one ready, we got Z leading to G. Take just a second to look over those. Write those down at home. All right, right. It's P leading to not T. C takes you to T. Now that already tells you, uh-oh, sounds like a contradiction going on there. G leads to C. E leads to G. And some of you are already going, Ernie, you got something wrong. Something's missing in there. Well, we're going to have to play with these a little bit. Going to have to play with it a little bit, all right? So let's first of all, first thing, remember what I said, figure out which letters are the singletons in here. Which ideas are we going to try to connect at the very end? I see, wow, what do I see? I don't see a repeat of P. Do I? Do I see a repeat of P, guys? I don't think so. And I see two T's. Oh, it looks like E is also going to be involved. So we got a relationship somewhere between P and E at the end. And some of you are going, well, wait a minute, Ernie. E leads on to G. Well, maybe we should start with E. And then that would bring us back to, oh, P is leading to something else. We got to play a little bit. This is what I said. We're going to be some of them. They're not going to be so easy. We're going to need to switch some orders here. All right? So everybody got it copied down. Let's start with P leading us to not T. All right? So I'm going to write it right out here. And they're probably going to take my picture away because I'm about to bleed right into it. But that's okay. All right? And some of you are saying, well, Ernie, I thought I would start with E, like the beginning letter of my name, right? Well, we'll do that in a minute. We'll set it out here also. And E was going to lead to G. We'll pick it up, all right? We'll pick that up here in just a second, all right? We'll try going in that direction. You can do either way. But you're saying, Ernie, one time you start with P, one start with E. We'll talk about it, all right? Just patience. Patience out there, folks. Now, I want not T in here. I've got a positive T here, so to speak. I've just got T, but I've got C leading to it. Remember what I said about a conditional sentence and its what? Contrapositive. They are logically equivalent. So here I have the idea of C leading to T. I need a not T right here. And remember what I said. Conditional sentence and it's contrapositive, so we are going to put the inverse of the converse or the converse of the inverse. However you look at it, we are sending C to a not. And I'm going to put this right down here so we don't get confused. All right? So you're saying, oh, got it. What do we need here? We need a not C, which guess what? Contrapositive time again. It's going to leave us to not G. Can we go one more notch? Of course we can. One more contrapositive, ready to go. Wow, we have really taken this thing and gone in all directions, haven't we? Going to be not E, and how about it? There's my P, and there's my not E. And that's okay, my friends, because that's actually the way it works. If P happens, we have to be having the opposite of E at the end. So in this situation, what this P is leading us to is not E. There's your value right there. Now, let's quickly go over here and see if we can get this thing running in order. Remember, we're going back to here. This one actually looks easier because you got E leading to G. G is set up ready to fire into C. C is going to take you to T. I bet some of you did this one the first time, didn't you? How many of you went with E to P? All right. But keep an eye where we're going here. Now, we've got E leading to G. All right. We've taken G to C. And we only have one more place to go, but look what happened. We got this not T happening. So here's what's going to happen. We've got to take the contrapositive, which means T is going to go positive, but look what happens. Opposite of P. So where do we end up? We end up with E. We end up with not P. And the question is, which is correct? My friends, they are both correct. Now let me tell you why. They're contrapositives to each other. So if this is working, then this guy's working. Conditional sentence and contrapositive. Or you can start here. Conditional sentence and contrapositive. Logically equivalent. There comes that big moment right there. Hope you guys got both of those right, one or the other. Like I said, I always like you to notice there's more than one way to work some of these problems, and that's what makes that a little bit of fun. Now, let's have a quick ending here. I think we're getting close to time on this, and I've got one more that would have been great, but we're going to hit this one, all right? We're going to get a little bit of the Southeastern Conference I think we got going on here. You know what we got here. We got the Wildcats from Kentucky. You guys are watching from up there. We got the Vols, which is, of course, UT, Tennessee. Tigers could be, oh my goodness, it could be Auburn, could be LSU. There are a lot of Tigers. Aggies, Texas A&M. You know, we're getting out that way eventually someday with this show. Commodores, Nashville, Vanderbilt. And you go, oh, wow, we're back at everybody's here again. So what we're going to do, we're going to code. So this says W leads to V. Oh my goodness. Wildcats waffling. I've already got some folks in Kentucky going, no, don't do that to us. Then the Vols are victorious. That would be Tennessee. All right. Now, Tigers are tentative. We'll make that T and leading to A, the Aggies, trying to adjust whatever they do out there. Then we got the Commodores coming in for the first time. They're hooking up with the Wildcats. And then the Aggies also, if they adjust, then the Commodores are going to crumble. What we want to do, figure out where are we going on this. Well, it looks like we're going to talk about T being alone. By the way, that T is for Tigers, all right? Tennessee's not tentative, all right? The Tigers are, all right? And the V is the other piece. So we're trying to get T to V having a nice relationship. So let's put this thing together here. Let's start with T leading to A. We're going to go in the positive fashion because guess what? Everything's positive. We don't have to worry about any negativity here, right? So no knots coming up. So we got T leading to A, so that part is done. We're going to take A picking up, going to C. And that one's done. We'll pick up C heading to the Wildcats. Yeah, they're going to waffle. Go Kentucky. And then W leading to the V. There's your ordering right there. So where do we do? We started with T, the Tigers, tentative. We end up with the Vols being victorious. And we have all the good stuff that goes on in between. What's your final conclusion? T, Tigers, being tentative, lead to victorious Vols. Hope y'all enjoyed that little trip through some logical ordering, okay? Coding sentences And we had one more about somebody marrying their macaroons or something, but we can get that on another show, okay? Maybe we'll work that into one of our live shows, all right? Hey, thank you for tuning in today. Remember, you can see this on Facebook, and we love it when you like us there. We love it when you share us. And these specialized segments are going to be announced there, but where you really get to see us is on YouTube. Loving that fact that we've got Facebook that picks up our problems today and tells you what we're going to be discussing on here on this show. But even better, you can see those live presentations of these Friday and holiday and weekday sometimes segments of specialized segments, but also problems of the day. Every day we have a problem of the day live on the show. When we're live shows, we've got it there too. Now, some of you may be watching us on YouTube. Some of you may be even actually streaming us and all sorts of other things. We are becoming more and more high-tech in this area, and we are glad, however you're looking at it, we're glad you're watching us. We want you to keep watching us. We want you to share us with your friends. Folks, if you're on Facebook, hit our thing and share what we're doing with all your friends and all sorts of things. Also tell everyone, hey, got to go subscribe to YouTube. But more than anything else, just watch the show, and we'd love to have you back. And we will see you again next time.